Hi everyone, note 6.5 are on finding missing angles of right triangles. So in the last lesson, we talked about how to find missing sides. Now we're going to talk about how to find missing angles. Okay, so the first three questions ask us to find the following values rounded to the nearest hundredth. So let's go ahead and type these in. So we're going to do sine, cosine, and tangent of 24 degrees. Again, make sure that you're on degree mode. So I'm going to type in sine of 24, and when I round that to the nearest hundredth, I get 0.41. Then I'm going to do cosine of 24, and when I round that to the nearest hundredth, I get 0.91. And then I'm going to do tangent of 24, and when I round that to the nearest hundredth, I get 0.45. So here I'm just going to type or write down that this is 0.41. This is 0.91, and that this is 0.45. Okay, so what this means is if I have a triangle that has a 24-degree angle, if I were to divide the opposite by the hypotenuse, my answer will be 0.41. If I were to divide the adjacent by the hypotenuse, my answer would be 0.91. And if I were to divide the opposite over the adjacent, my answer would be 0.45, no matter how big or small my triangle will be. Okay, and just a reminder, it's always sine of an angle, cosine of an angle, tangent of an angle. So this is all good if we know the angle, but what happens if I don't know the angle? So like, for example, right here, this says solve for x, round to the nearest degree. So this says cosine of x is equal to 2 over 3. So this time, what's happening here is if I were to draw a picture of it, here's my right angle. Here's the angle that I want to find out. And I know that the adjacent is going to be 2, and that the hypotenuse is going to be 3 because cosine is adjacent over hypotenuse. So how would I figure this out? So what would I need to do in order to figure out what x is? Well, if I have, you don't have to write this down, but if I have x plus 3 equals 12, I would solve by subtracting 3 from both sides because the opposite of addition is subtraction. If I had x minus 3 equals 12, I would solve by adding 3 to both sides because the opposite of subtraction is addition, right? If I had x squared equals 25, I would solve by square rooting both sides because the opposite of squaring is square rooting. If I have 3x equals 12, I would solve by dividing by 3 because the opposite of multiplication is division. We know all these inverses. So the question is, what is the inverse of cosine? So right here, the inverse of cosine is something literally called inverse cosine. So this is called inverse cosine. And what I'm going to do is I'm going to find the inverse cosine of the number 2/3 of this right here. So essentially what we're saying in our calculator is tell me what angle will give me a ratio that will give us an adjacent or hypotenuse that would be 2/3. So let's see how to type this into our calculators. I'll show you in class how to use the class calculators to do this, but on Desmos, this is what we would need to do. We would need to click on this function key right here. So I was in main, I would click on the function key, and then I would do inverse cosine of, I'd go back to main, and I would type in 2 over 3. So this would be inverse cosine of 2 over 3. So my answer here would be 48 degrees. So this answer is 48 degrees. You have to show this line of work when you're doing this, okay? I want you to write this down on the side over here, please. So if we have cosine of x is equal to 2/3, a lot of people will say this is cosine times x, and then they'll think I'm just going to divide both sides by cosine. Watch what happens when I do this. So I'm going to type in 2/3, and then I'm going to divide that by cosine. Notice how the calculator is asking me to put in an angle. It's cosine of what, right? So this right here does not mean cosine times x, it means cosine of some angle x. So this right here does not work. So I want you to write yourselves a note to not do this. This is incorrect, okay? All right, so in number 5, same thing. The x is inside of here. The opposite of sine is inverse sine. So I'm going to take the inverse sine of 0.5. What does this mean? What angle will give me a ratio of opposite to hypotenuse of 0.5? So let's go ahead and type that into our calculator. So we'll clear that out because that's ugly. We never want to do that. So I'm going to go to function. So I was in main, go to function, click on inverse sine, go back to main, and then I'm going to type in 0.5, and I end up getting right here 30 degrees. So right here, x is 30 degrees. I don't have to do any rounding at all. Okay, go ahead and try the last one on your own. Pause, see how you do, and then come back to check your answer. Okay, so for this last one, I'm going to do inverse tan. So to get the x out of there, I have to do inverse tan of 4/5. Okay, so here I'm going to type that into my calculator. Again, I'm going to go to function. I'm going to do inverse tan of 4/5. And I end up getting 38.6598. Round that to the nearest whole number, I get 39 degrees. So x here will be approximately 39 degrees. And I apologize, this here should say x is approximately 48 degrees. Okay? Okay, so let's put this into practice. So for 7 through 10, we're going to solve round to the nearest whole number. So I'm trying to find this angle right here, which we're going to call angle theta. So I want to know how the 14 and the 24 relate to angle theta, because those are the only two sides that I know. And so this 14 is across from it, so this is the opposite. The 24 is always going to be the hypotenuse because it is across from the right angle. And I'm just going to write out SOHCAHTOA on the side right here. And I know that sine of theta is going to be 14/24. So to get that theta out of there, I have to do the inverse sine of my ratio, which is 14/24. So again, I'm telling my calculator, what angle will give us opposite over hypotenuse equal to 14/24? So let's go ahead and type that into our calculator. It says round to the nearest whole number. So go to function, go to inverse sine, type in, go back to main, type in 14/24, and I end up getting 36 degrees. So this right here is approximately 36 degrees. And this is my final answer for number 7. Let's take a look at number 8. So in number 8, we are given this angle right here. We're trying to figure out this angle theta right here. Okay, and I can really use any sides that I'd like because I'm given the opposite, the adjacent, and the hypotenuse. So we have everything that we need. We have all 3 ratios. So we can choose which one we'd like to do. I am not going to do sine because we've already done sine in number 7 and I'd like to try something different. So I'll just use the adjacent and the hypotenuse. So adjacent over hypotenuse is cosine right here. So I know that the cosine of theta is going to equal the adjacent, which is 24, over the hypotenuse, which is 74. So to get that theta out of there, I have to do inverse cosine of 24/74. So I end up getting theta is equal to approximately, we go to our calculator, we go to function, we do inverse cosine of 24/74, and we end up getting 71 degrees. So this answer right here is approximately 71 degrees. Okay, let's do the same thing with this. We'll find out angle theta, but this time I'm going to use a different ratio. So let's try tangent because we haven't done tangent yet. And tangent is going to be opposite over adjacent. So let's try tan of theta is going to equal 70/24. So I can do inverse tan of 70/24. And I end up getting theta is equal to approximately, so I'll go into my calculator, I'll type in 70/24. Sorry if I said 7/24 earlier, I meant to say 70/24. So I'm going to do inverse tangent of 70 over 24, and I end up getting the exact same answer, which is 71 degrees. So notice it doesn't matter which ratio you choose if you're given all three sides. Okay, so we have our final answer of 71 degrees. Okay, and if I were to use sine, I would still get 71 degrees. All right, in number 9, I need to draw a picture of what's going on here. So it tells me that a piece of lumber leans against a wall. So right here, this black line right here represents the wall, and then we have our piece of lumber that's leaning against the wall. The top of this 40-foot piece of lumber, so we know that this is 40 feet, touches a point on the wall that is 36 feet above the ground. So that means that from here to the ground is going to be 36 feet. Okay, find to the nearest degree the measure of the angle that the lumber makes with the wall. So I've got a right angle here. So the question is, am I trying to find this angle right here, or am I trying to find this top angle right here? Because it says find the measure of the angle that the lumber makes with the wall, it would be this angle right here. Okay, so this is what I'm trying to figure out. So I'm going to label this as angle theta. If it said find the measure of the angle that the lumber makes with the ground, then it would have been down here. Okay, so we've got two sides. We need to identify what each one of these sides is in relation to our angle. So 36 is the adjacent, 40 is the hypotenuse. I'm going to look at SOHCAHTOA right here, and cosine is adjacent over hypotenuse. So I would say cosine of theta is equal to 36 over 40. To get that theta out of there, I would do inverse cosine of our ratio 36 over 40. So let's type that into our calculator. Go to function, go to inverse cosine. I would go back to main, type in 36 over 40, and I end up getting 25.8. And I believe it asks us to round to the nearest degree, so I end up getting 26 degrees. So that's what theta is approximately. Okay, all right, next page, just our last question right here. Safety bylaws state that for a ladder to be stable, angle this should say that the base of the ladder makes with the ground should be between 70 and 80 degrees, okay? A safety inspector at a construction site notices a painter on a 10-meter ladder that is leaning against the wall. The base of the ladder is 1.5 meters away from the wall. Does the inspector have cause to be concerned? So let's draw a picture of what's going on here. So here's our wall, here's our ladder. That's going to give us a right angle. It tells us that the ladder is 10 meters long. So this right here would have to be 10. And it also tells us that the base of the ladder is 1.5 meters away from the wall. So this right here is 1.5 meters. Okay. And it says right here that the angle that the base of the ladder makes with the ground should be between 70 and 80 degrees. So they're talking right here about this angle right here. So this is angle theta. So I'm going to look and see how is 1.5 related to the angle. It's the adjacent, and the 10 is always the hypotenuse. Seems like we're doing a lot of cosine in this example, in these examples here. We're going to do cosine again because we have adjacent and hypotenuse again. So I'm going to say cosine of theta is equal to 1.5 over 10. So here I would say theta is the inverse cosine of 1.5 over 10. So let's type that into our calculator. And I end up getting 81 degrees. So this is approximately 81 degrees. It should be between 70 and 80 degrees. This is more than what it should be, right? It's above the 80 degrees, so this is not going to work for us. So we can say that the inspector does have cause to be concerned. So therefore, the inspector should be concerned because the angle doesn't fall within the required range. And that's it for this video. Let me know if you have any questions, and I will see you in class. Bye.